In these notes, we are going to review how to graph linear inequalities. And I have given us steps for when things are in slope-intercept form, which is y equals mx plus b, and standard form, which is ax plus by equals c. Remember that when it comes to inequalities, we use a dotted line when there's no equal sign, and we use a solid line when there is an equal sign. So I'm going to go down to my example, and I'm going to start with our first equation, which is y is less than x plus 6. This is in slope-intercept form, so I'm going to follow these steps. Step 1, graph the y-intercept on the y-axis. My y-intercept is 6, so I graph that point on 6 on the y-axis. My second step is to graph my rise over my run, or my slope. I know that my slope is 1, and I'm going to make it 1 over 1 so that there's a rise and a run. It's positive, so I know I want my line to go up. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1, down left. And I'm going to do that throughout my entire graph. My third step is to decide which type of line to use. Well, because we have a less than, we're going to use a dotted line. This is already a dotted line, so I'll just emphasize it a little bit more to make it obvious. Step 4, read the inequality from left to right. If you say greater than, shade over the y values that get bigger. If you say less than, shade over the y values that get smaller. Well, we said y is less than, so we're going to follow step B and shade over the y values that get smaller. The y values get smaller going down. Here's 0, 0. Everything going down is negative. So I know that I want to shade this side of the graph. Now I'm going to start graphing my second equation. 2x plus 4y is greater than or equal to 8. This is in standard form, where x and y are on the same side. So I'm going to follow these steps to graph. Step 1, cover up the y and solve for x. So I cover up y, leaving me with 2x equals 8. We're going to ignore the inequality right now. If I were to isolate this, I'd get x equals 4. That means my x-intercept is 4, so I'm going to put a point on 4. My second step is to cover up the x and solve for y. I cover up x, 4y equals 8. I divide by 4 and I get y equals 2. This is my y-intercept, so I put a point on 2. This is the easier way of graphing when in standard form. You can also solve this to solve for y. So if I wanted to do that way, this is an option. You don't have to. You can choose between either finding the intercepts or what I'm about to show you. I would subtract 2x, leaving me with 4y is greater than or equal to negative 2x plus 8. Divide by 4 and get y is greater than or equal to negative 1/2 x plus 2. Either way is completely fine. Now we're on step 3, where we need to decide what type of line. Well, because it is a greater than or equal to, we're going to use a solid line. So I'm going to connect my graph using a solid line. Now, we're going to go to step 4. We can't use this step because we don't have y by itself unless you did this, in which case you could use that. Greater than or equal to means we shade up. But if you don't want to use this way and you wanted to use the intercepts, then you'll follow step 4 over on the right-hand side. You're going to plug in a coordinate, which is x and y, on either side of the line. So I'm going to pick a point on one side of my line. I like to pick 0, 0 because it makes the most sense to me because it's super easy. If I solve my inequality and it's true, I'm going to shade that side. So if I plug in 0, 0, and it's a true statement, I'm going to shade on this side. If I solve it and it's not a true statement, I'll shade on the opposite side. So I'll show you what I mean. I'm going to plug in 0 for x and 0 for y, and bring everything else down. This gives me 0 is greater than or equal to 8. 0 is not greater than or equal to 8. This is false. 0 is smaller than 8. That means that I don't want to shade on this side because it's an untrue statement. I'm therefore going to shade on the opposite side. The solution is where I have both shadings covering each other. So you're going to notice that we have 1, 2, 3, 4 different sections of the graph right now. I numbered them arbitrarily. It doesn't matter how you number them. 1 is not a solution because there's no shading. 2 is not a solution because there's 1 shading. 3 is the solution because both of my lines have their shading overlapping it. Therefore, this part is my solution. That means if I picked any point in this section and plugged it into either of the equations, this statement would always be true. So I could plug in 2, 4, 3, 8, 6, 1, 8, -1. Anything that's in here where both of the shadings are is a solution.